I'm Dakshit Agarwal. I'm a PhD candidate here in the computer science department. I'm studying machine learning. My research is in machine learning on structures. And this course is particularly a mixture of my different interests and my research space. When I came into UCSC, I wanted to work in social good, and there was a specific field named ICTD, Information and Communication Technologies for Development. And that field basically dealt with different aspects of how technology can be applied for social development, how can we use technology in different places, developing nations, many social scenarios. Then over the course, as I studied more and more machine learning, I've tried to build this content which is applied machine learning for social good, where we are focusing from the point of view that, let's say, we know certain level of machine learning, maybe intermediate or expert level, and we want to apply it to real world scenarios, mostly concerned with societal challenges. Right, so that's the course. I'll begin with the general information. As you know, the class will be Tuesdays and Thursdays, 11:40 to 1:15. There's a class website, and it will be updated with all the information going forward. I already have the syllabus laid out in terms of what I'll be covering in the lectures. But in totality, the class will have all the content, the videos, lectures, everything will be on the website. My office hours are going to be on Monday, 11:30 to 1:30. This is in E2, second floor, 239A. I won't be available in that room this week, but otherwise, please mail me if you can't find me in that particular room. But I should be available Mondays in that particular location. There's also an inquiry form attached on the site as well, attached on the slide, which can be used to just ask any questions. It's just a way to serialize the process so that if I lose anything in the mail, at least in the inquiry form, I have all the information. And as I said, the site will be webcasted. The link will stay same, and it's a recurring event, so it will happen every Tuesdays and Thursdays throughout the quarter. And you can just install Zoom, sign in using UCSC account or personal account, but UCSC provides a Zoom integration, so you can use that and then access this. Okay, course objectives. As I said, the course is about applying machine learning for social good. But in that, one thing that we need to study is how technology can impact society. And this is across broader dimensions. So technology and society have sort of have this relation at every stage. Whatever is the latest in technology, we can observe that it is impacting society in some way or the other. Social networks are the latest ones that are clearly visible, that with more and more development in social networks, with the internet-based platforms, how society has transformed. But over the course of time, this change has been visible. And at every stage, whatever is going on with technology, whatever is the new stuff that we can develop, we can maybe use it up to some capacity for social good and for a change, for a positive change. And that is where we will study that how can we apply machine learning in particular, a small segment of technology, for different societal challenges. So misinformation, for example, is is an issue that's currently taking place. So widespread misinformation has actually impacted democracies, and it's continuing to do so. Can machine learning, with its different abilities, be used to tackle at least a small part in that problem? Even if we can fix maybe the distribution or maybe some validation of the content. Can that help? So there are different sizes in which we can make that progress, and we'll study whether machine learning can be used to do that, and if yes, how? How can we actually build that pipeline? So we'll be, at the end of the course, I expect that every student will be able to build a fully functional prototype, which means that you can look at a problem, you can structure it into a learning problem. So you look at a general problem, right? Create the definition out of it, structure it as a machine learning problem, build the entire pipeline to solve it, and be actually able to deploy it. So it's not just sitting in as a set of results that, yes, I had the accuracy of a certain presentation. No, you actually have a model which is trained, which is a learning model, which maybe predicts something, maybe validates something, detects, but is ultimately being deployed in a real application and is being used. So by the end of the course, you should be able to do that. And you'll also be able to evaluate a system not just on standard metrics, as I mentioned, like accuracy. You'll be able to evaluate across different metrics. So, which means machine learning metrics as well as real world metrics. Because the problem is not really emerging from a challenge or a data set. The problem isn't real. You're creating an approach out of it, and then you want to evaluate whether it impacted the real problem completely, right? So it's taking in, building the problem, and then going back, evaluating it. So that journey will also be covered within the course. Some quick run through like the basics. So grading will be broken down into 4 pieces. One is readings. So every week we'll have a set of readings, and it's not going to be too heavy, but some readings, some weeks will be heavy, but mostly it's like a convenient size. And we'll have discussion in the class, and we'll have discussion on the forum, which is Piazza for our case. But and that would be one component. Class participation is second, which is somewhat related to readings and more discussions in the class. So oftentimes what we'll have is that we are doing a case study or we are doing analysis of a social issue, and we need to just build up a discussion on top of it, and there's no structured content. And that is where class participation was more important, because a small classroom, I'm figuring at some points we'll be just discussing some problems. Assignments, there are going to be 5 structured assignments, 4 of a certain smaller type and 1 full system. I'll go over this later. But the assignments will be 40%, and then there's a final project, which is the full system that I was talking about. You'll actually have a deployable system, a live working system, deploying some machine learning method, targeting the societal challenge. The tools, there are some decided, some we can discuss. Piazza is the main platform for any communication. If you want to ask questions, if I'm doing any announcements, anyone who has enrolled into the class should already be on Piazza, or should at least receive the mail. But otherwise, there's a sign-up link, so you can also sign up on Piazza. There's no restriction of particularly being in the class to join the conversation. We'll host the reading discussions on Piazza, and any question, any concern around assignment, everything goes over there. CrowdGrader we'll use for some assignments where there's a basically there's a piece of code that you're submitting, and then students will review that, and it's going to be small collaborative. So the task of reviewing would be that you're actually looking at and assessing their code, while also learning some things which are maybe a different approach, or some things that you could not figure out in the first place. And the second aspect is that whenever you go to industry, like code review is almost as important as writing the code. So this would cover, this would be sort of a minor practice into that. I'll set up a Google Team Drive. The main purpose of this is to host datasets, so that you have a particular location from where you can access datasets. If you find any other dataset and it's public, like the license allows you to copy it, then we can put those on the Google Drive as well. But this will be sort of a centralized location where if we want to do any data dump, we can do it. So I'll set up a course. It will be a UCSC Team Drive, and you can access it using the UCSC Gmail account. And all the data sets and some code snippets would be there. Canvas. This is something where I would actually be interested in opinion, generally from students who are using it. We can host discussions on Canvas. It has a platform for that, but Piazza works really well. So is there any opinion, like anyone in support of Canvas? Everyone against it?
Yeah, no. If you decide to don't use Canvas, where do you post documents on the syllabus for the class?
Course website.
Course website. Yeah. There's lots of options to look at using UCSC. So
yeah, this is a Google, not the, so on the SOE there's a link to the Google site, which is also a UCSC hosted sites.
Okay, so you go to the SOE webpage, and then the standard class webpage.
Yes.
Okay.
To UCSC.
I'm asking that because some people think Canvas is the standard site,
right,
because it shows up automatically. So if they're enrolled in the class.
Right. Okay. So on the Canvas side also, I'll at least put the link to the class website, so that if anyone is taking that route, they will move that. But we might use Canvas for final distribution of grades, but I mean, that's up to your choice. So if you want, I can include Canvas. Otherwise, I can use different ways.
Have you already published the Canvas website?
It's automatically published. So I don't, basically, if you enroll into the course,
So
on
I
your
have
Canvas,
the answer one, but I didn't get the Canvas. Everybody
No,
else.
you have to hit publish.
I had to,
Yeah, it's you.
oh, so it's on email?
Yeah.
The instructor has a big red button that says publish this course.
Okay,
I don't know whether TA normally see that, but the instructor has a
right. Okay, so I will publish the class if we decide to go forward with Canvas. Another thing is Slack. So Slack is really good for collaboration if you want to host discussions. But if you want to do very organized discussions around, let's say, a paper, then it would not be the best platform. But if you just have, maybe you want to create project teams, and there's one channel for the entire course, then we can use Slack. So is there any preference? Have you used Slack maybe in industry or for any other course? Is there a preference for using
course
it?
ITA for instructor creative Slack.
Okay. Okay. So I'll create a Slack. So I have a Slack for MLN Society, and I will create a particular channel inside it. I'll enroll. So again, anyone who has already enrolled, you'll get a link to that Slack, and we can decide how to use it. But mostly for the official announcement platform is going to be Piazza. So if there's anything really important and something that you always have to check, that's Piazza. But if it's more convenient, because one thing that's helpful in Slack is app integrations. As we will do like different code pieces and you're using a GitHub repository or Bitbucket, you can integrate that into Slack. And then if you have a project group, all that discussion is actually in one place. So any update on the code also shows up there. There are several advantages, but Piazza alone also works. So we can decide, I'll set up a Slack. And same with GitHub. One of the elements for assignment is going to be Colab notebooks. These are Google IPython notebooks, hosted you using Google Server, Google Cloud resources for them, and you can access them using your Google Drive. They have a default integration with GitHub. What happens is that if you set it up, you can save all your progress of a notebook into a GitHub repository, and it keeps updating as commits over there. So if you're interested and comfortable with GitHub, we can use that as well for code review on the notebooks. But again, going forward, when we reach at the assignment stage, we'll decide. These are two options which help with the code review process and not much with the course. Any questions around this? Okay, so this is how the course will look like in total. Week 1 to 3 are the basic building blocks. I'm assuming that everyone is comfortable with programming in general, but may or may not know machine learning at a maybe very, very early stage or maybe expert, but I'll go over some of the machine learning concepts right in the beginning. But this week would be introduction today. Thursday would be more depth into AI, social good challenges in general. How do we analyze problems in the social space? What is the research out there, and what are people doing about it? That will be covered on Thursday. And then next week would be purely machine learning. So we'll go over the basics. What are the concepts? How do you structure a problem in machine learning? What are the very basic algorithms? Then going into an advanced stage on the next week, where we'll introduce deep learning, neural nets, and there's a data to inference pipeline, which will be an important part throughout the course, which means that once you have figured out what your problem is, you're trying to solve a certain problem, you create a data set or you have access to a certain data set. From that point to finally bringing a solution from your machine learning pipeline, how does it work? So an overview will be covered on week 3, and then going forward, we'll actually implement it. So week 1 to 3 are basics in ML and basics in real-world challenges. Week 4 and 5 are going to focus more on the social good side, where now with some knowledge of machine learning, we'll actually formulate a social problem into a real solvable problem. We'll break it down into like a machine learning problem at different pieces, and then try to determine how data sets can be connected, how are we actually building the full picture of this computer science problem to solve. It's not like the original problem was a social problem, and now you create a computer science problem out of it, and then you create like small machine learning problems out of it. And we'll also go over metrics and evaluation. This part is important again to analyze what is the real impact of a machine learning based solution. I mean, are we actually going to be able to make any real impact on a bigger problem, or from the small task sense, like misinformation? Are we going to be able to figure out at least more than randomly picked probability whether a news article is fake or not? If our learning solution can make that tiny contribution, it's at least some addition, right? And then you can evaluate it. You can have real metrics to determine, okay, what is the quality of the contribution? And that's how a solution will be evaluated. So in machine learning, you cannot claim that, okay, now that I have a solution, my problem is fixed forever. It never really happens, right? So you will judge it with different data coming over time. So one would be that when you start the problem, you create a validation set, which is a small data set, which you're using just to build up the model, evaluate while being in the process. Okay, how is it working? Is it really working well at all? And then you collect data spread over time. Maybe if you had a large data set, we break it down up to a certain point and build the model on top of it, and then see from the real data that was available outside of the time window whether a solution would have made an impact on that. So you're really analyzing it in terms of time, whether your model will work or not. So that's the real evaluation. And also you will analyze in different ways, like qualitative ways, that the solution that you're providing, is it actually going to make an impact on the real scenario? So that's week 4 and 5, where we'll cover how to do this analysis. Week 6 and 7 will be more around building a particular system. So this is going to be the time for the larger assignment. When you'll actually, so it would be built on some boilerplate code that I'll provide, but you'll actually be building a fully working system where you have a certain data set, it goes through a full machine learning pipeline, and you're getting a result. But it would be up till the machine learning result side. You're not building an application on top of it to deploy the results. But as week 7 will cover that. Week 8 would be some more concepts of machine learning. We are not going to go over full detail, like recommender systems and ranking. These are the spaces which are, I mean, they are separate fields, but at least on an applied side, you can just understand how it works and then use them up to a certain extent. In our case, recommender systems would actually be really helpful in any large-scale deployment scenarios. I'll go over them in detail as we reach to that point. But the idea is that when we cover the basic ML and the neural net side, we're focusing on prediction. We're focusing on maybe detection and the standard classification kind of problem, right? But many applications require just recommendation. You don't know what the ground truth is, but you know two sides of a certain situation. In a farmer scenario, you have many small-scale farmers who have some like distributed access to markets around them. And these farmers are able to do a certain level of production based on the land and the weather and crop they are working with. But they don't really know which markets are the right ones for them. And if we have certain data on both sides, just a recommendation problem would actually take them to the right marketplace, which in the current scenario might not be accessible to them directly, because they just maybe know up to a certain extent, yes, we can go here, and whatever is the traditionally known knowledge. But if you can build a system on top which can do a more calculated, which can do a more calculated detection on this thing, like you are recommending them places where you can prove them, they will get better output just because maybe there's more requirement for their particular crop over there. In that, joining that particular link is going to be helpful in a real world scenario. So that's one side we'll also cover, but this will be more on applied. We won't be building the algorithms within recommender system. We'll be using those algorithms, and I'll cover how to use them, how to make them a part of your pipeline. Maybe if you have a bigger system where you're doing certain kind of prediction, but that result can feed into a recommender system. We can go over that. And then there's this data extraction and APIs thing, which is important when you want to build a system where maybe there's not a single data set that's available, but there are different sources. So weather data, for instance, right? Maybe you have some large dumps of weather data, but even if you don't, if you're building a system, you can write an API, like you can use a API from Wonderground, and that would continuously give you weather data, like regularly updated. Similarly, if you want news, maybe you can set up the Twitter search API, and every day you're getting a big feed of information on the required space, and you are using that to solve a certain problem. So there's a wide space where data sets readily are not available, but APIs are, and we can integrate them live into the system to build our own data set while working on a solution. And that's a critical part which we'll cover towards week 8. Week 9 will be about final deployment stage. So you have a solution that works. What's a small way in which you can build a prototype and just deliver it as an application? So we'll go over like, is anyone, do you know Flask, a micro web server? So Flask is a Python web server, which is sort of like tiny. You can just build a single page server or just like a very tiny single database server. And what it allows you to do is integrate any kind of Python code that you have with a web application right on top of it. So build up a framework, which we will use in the class towards the end, and which can be used in the projects also, to deliver the ML-based solution as a web application. So it's not that you're telling someone to just, okay, take this model and then try to deploy it. You're actually giving them this full working pipeline that if you just feed in data over here, or maybe we are gathering data as well, but here's the web application to just interact with the results, or maybe a graph, or that can different kind of ways to solve different projects. But this web application would just provide a final interface for a user to interact with, and it's going to be fairly simple. Everything is going to be in Python. So the two main libraries that you're using for code, TensorFlow and PyTorch, both can be used, Flask can be used on top of both. So I'll build up all the framework and it should be easy. And in the last week, we will go over help with the project, review of content, any special topics if you want to cover. So similar to ML in society, if there's a topic of AI and ethics, we can probably go over that towards the last week. And there's going to be room for anything additional that we want to discuss and the final project presentations. So around the course, are there any questions? Throw the time in.
Do we have an assignment or recommendation system or?
No. So the assignments will be till this point, week 7, and then it's on project. So the final time can be spent on projects. Readings will still continue. We'll be doing readings towards the end as well, but the coding assignments will be till week 7.
The coding assignment is incremental or is separate for?
There are going to be 2 incremental, so 4 total. I'll go over that portion, but so there are going to be 4 small assignments. It's mostly incremental, but not completely. You're not really building a full system on top of it. But I'll go over those details. Any other questions or suggestions? Okay. So so readings. The topics that we are going to cover in readings, one is technology for development, not centered to ML, but in general. Technology for development is a wide space. There has been continuous research. Davis has been a part of that community. So and there's big space of research in technology for development. Then AI for social good. This is sort of newly emerging. There has been recent interest. So NeurIPS and ICLR, two of the 3 main conferences in machine learning, hosted workshops for AI for social good. And there has been work from at Chicago, at CMU, and then Google is also getting involved in the space for AI for social good. So recently, there's a lot of interest, and there's also a big report from McKinsey, which is going to be a part of the readings. But so McKinsey has an institute for global studies, and they have actually created a very good report of how AI can be applied to different spaces of society and going over different goals. So we'll cover readings of that nature, where you either have an analysis of how AI can be applied for social good, or you have real examples. Then there would be some readings around ML concepts. Some of these are going to be optional, some of these required in the sense that your assignments are attached to it. But I'll basically have a good collection of resources for anyone to brush up any concepts in ML. If you're already comfortable with those, no need to go over them, but at least there will be resources available so that you can just follow through the class. And then some in applied ML. So what happens is that when we go in the research paper space, most of the research papers published in ML conferences are going deeper and deeper into the concepts. So you have a certain concept of, let's say, attention mechanisms in neural networks, and then the papers around that assume that to be the given knowledge and go more in depth, right? So there are certain papers which are more applied in nature where you touch on those concepts, but then are actually solving a full-on problem, and that's the side of reading in applied ML, which I've covered. So some research papers which are more applied, and some blog posts from TensorFlow blog or some Medium posts, basically some resources where you can see clear application of ML-based systems and not just the theoretical concept of it. How we'll go over readings is that every Tuesday we'll have a certain time allocated to discussions, and there's no particular pattern in which we'll be discussing the readings. We'll have a list of readings and then we'll go over them, let's say one by one, but this can be like a student-led discussion. If anyone really wants, anyone likes a particular reading a lot and wants to sort of lead the discussion around that, we can do that. If you want me to lead the discussion, we can follow that approach. But in general, we'll go over a paper and sort of try to analyze what is it that they're covering, how does it impact, and what are the opinions around it. And then the same would happen on Piazza, where I would want everyone to submit like some review. It doesn't have to be like a full lit review. Some review on what the paper talks about, some comments and opinions, which means that, okay, if they are using something, do you have any idea or how can we take advantage of that particular concept, or how can we improve that maybe, or any opinion around that? Do you question any approach? Do you like really do you like an approach that was used in the paper and maybe not highlighted sufficiently? So just any points around the readings. If you have those, we can host a discussion on Piazza. These will also be play a component in the class participation rate, but they are primarily the reading rate. Any questions around readings?
When and like where are you?
So everything is going to be posted on the class website. So class website will have a compilation of all the course content, the lecture videos, the assignments, readings, everything will be on the class website. And anytime I update anything important on class website, I'll post on Piazza. So the announcements will be through Piazza, but content will be on class website. Any other question? Okay. Next is assignments. So there are two kinds of assignments. One are Colab notebooks. So Colab notebooks are, anyone has used Colab notebooks? Okay. So Colab notebooks are IPython notebooks, which means that you have an interactive interface for writing Python code, where you can write the code, run it, and see the results right on there, and it retains that. Colab notebooks are the same IPython notebooks hosted on Google Cloud. You can make them a part of a Google Drive. You can create a new Colab notebook from your drive. And the best advantage is that you can access a GPU. So if you don't have a powerful machine, you can still write good neural nets and train them. You cannot run like code that takes 40 hours to train on Colab notebooks because there's a session time limit. But anything small, anything which still needs certain GPU compute power, you can use that. They most definitely have K80s, which are fairly good. But that's the best way to run. Basically, resource won't be an issue if you want to run any neural networks or any heavy problem. For data, again, no issue because these are hosted on top of Google Drive. If you're using your UCSC account, you can just host data on the Google Drive, access it directly over there, and there's no size limit. So any large data set can actually be used directly on Colab. And the assignments, how they will be that I'll structure a certain boilerplate code that this is what we need in this assignment, and then you'll have to work at like write the solution or write the code on your notebook, and then the notebook would be submitted, and it's a snapshot thing. So if you keep on improving that later on, that's fine. But when you submit, you will submit it at a particular timestamp, and that snapshot will be submitted. So every notebook has a revision history. The submission will be at a particular stage, like whatever is due before the due date, right? And that's what will go into the review. But for your practice, if you want to continue, you can just keep working on that notebook. And code review will be a separate process within assignments because, as I mentioned, like it's a helpful process. It's the best thing that comes out of code review is looking at different kind of solutions. Even if you had, if you were able to solve it, but if you look at someone else's code, you see a totally different approach. Maybe that's what you want to follow later on. It just helps a lot. So code review process will be a part of it. Any questions on Colab notebooks?
Where do these Colab notebooks come from? Do you make these yourself?
So by default, you can just go on Google Drive and create a new Colab.
Oh, I thought you were the homework assignments came with. You're asking us to do it.
No. For the homework assignments, I'll provide you the base Colab notebook, and then you can make, basically you will make a copy of it. You'll have a boilerplate Colab notebook, which has some description, maybe some starting code to load the data set, to work up to a certain level, and then you have to write your own piece of code. That is where you basically write your own notebook. So it will be a copy of my base notebook.
Hmm. Yeah, I was asking if you made the base notebooks or if you took them from somewhere, just because I think that's impressive. You make the base notebooks. It's a lot of work.
It's going to be all mine. There's no other base that we have. Maybe some snippets from the TensorFlow notebooks, but not beyond that. So it's going to be all separated. And any other questions around notebooks? Okay. So the larger assignment is going to be a computing system, which is not in the form of notebook, is actually full structured code, where you have a fully working ML system. What this means is that there's a data set attached. There's a code file which is dealing with how to load that data set in, maybe extract features out of it, and you build the data up to the learning level, like how to set the data for your learning algorithm to work. Then there would be code for writing the learning model. So let's say it's a neural network model and you're writing convolutions, which we'll cover in later sections. But if you're writing that piece, there will be code for that. It's not too difficult if you're using TensorFlow or Torch, but that will be a part to be covered. And then third would be the validation, the evaluation part. Like if you have built up a system, how are you evaluating it? So these three phases, by the time we reach this particular assignment, they'll all be covered in some way or the other. You'll have enough snippets from the class to go over this. And there would be choice for using TensorFlow or PyTorch. So early on in the class, I'll be using more of PyTorch, but TensorFlow has recently announced TensorFlow 2.0, which is quite different from TensorFlow in general. So it basically follows a concept of eager execution, which means that you have everything readily available and it's not going to be compiled later. It's totally a backend thing of TensorFlow, doesn't matter much, but that's in alpha stage. So I'm waiting to see how well that is working, and I'm testing TensorFlow 2.0. If it works really well, if it's bug free, then we'll use that as well. But in the beginning, we'll be using mostly PyTorch because it works really well. And if you have experience in any of the two, feel free to use that particular library. The way TensorFlow 2 is structuring the code, it's not that much different from PyTorch. It used to be very different, but now they're sort of coming along similar lines. But yeah, feel free to use either of these. Now, any questions particularly on the complete system?
Are we restricted to do one of those two projects, or?
Yeah, I mean, if there is, this is not a project, this is an assignment.
Yeah.
So for the assignment purpose, I want to limit to like, because you want to have something verifiable at the end, right? In project, yeah, you can use anything.
Have you already kind of created some, or do you have some idea of which task you have for each one of those?
Yeah.
Can you give us like a one-line summary, right?
Yeah, so for neural machine translation, it's actually going to be very similar to the tutorials that are out there, that you have a corpus on which you're doing translation. So let's say you have German to English translation. There's a large data set that's available to train a model, to train a neural machine translation model to translate the text and then actually evaluate it right on top of it. And what we'll be doing would be something similar, but we'll be using data sets from the social good domain. So there are many text data sets which will be sort of mapping up to neural machine translation. And that process is I'll go over it later on. But that's one side. Image classification is one of the most popular applications. So in neural nets, in the success of neural nets, image classification has sort of been the primary reason why they became so popular. The task is that you have images and you have classes, right? And you're trying to train a model which just looks at images, maybe no feature extraction at all. And the neural net is responsible for doing the feature extraction, like learning the feature extraction on the way. And the famous ones are like, there's a data set called CFAR10, which has 10 different classes. And you're just basically doing like, it's a big data set and you're classifying them into like dog, cat, car, I think. So there are 10 specific classes in CFAR10. So the image classification task would be around classifying objects. So we'll have, how we'll do these things is that we don't have good social good domain data sets to train powerful models, but we have smaller data sets to sort of fine tune them. So we'll be using publicly available data sets to train the base layers of a certain model. And then there's a concept called transfer learning, where you have a pre-trained model and then you're training it further for your particular data set, which is how we'll use them. So that's going to be the larger assignment on week 6 and 7. Again, yeah, code will be in TensorFlow or PyTorch.
So there's 4 and 1, so almost 1 per week for the first 6 weeks.
Almost. Any other questions around assignments or the full complete system assignment? Okay. Another thing is, like, if you have access to any good data sets in social good domain, which may be public, which may are like restricted access, and you know how to access those, maybe it would be a good idea to discuss that as well, and you can use them in the assignments or the project. But I mean, if you have access to any social good data sets. Okay, project would be the final phase. Project preferably in small groups, like up to 3. What we want in a project is, again, an ML-based solution, but now this is a full working prototype where you're delivering the solution in the form of an application. And you're also building like how the data is coming in to the pipeline. You're also responsible for that. Like in the assignment, there's going to be a data set. There's going to be a lot of built up framework, and you're just connecting the dots. Whereas in this thing, you'll be building the entire pipeline from where you begin with you have you look at different challenges, try to build up a solution, right? Look at the different data sets. This is not something where you have a specific answer that, oh, I always get 90% accuracy, or if I get accuracy beyond a certain percentage, then only it's a good project. No, it's more of subjective. That looking at the problem under concern, are you able to build a solution? Are you able to solve certain small elements within the larger problem? And build this entire pipeline of training a model, applying different ML algorithms, building up the solution, evaluating it, maybe retraining based on different evaluations, and building up an interface on top of it to deliver the final solution. Because I'll be providing you the framework to build the web setup, I'll also teach along with it how can you host it on cloud, like Google Cloud or any other cloud. And the final project should be hosted on one of those clouds. Or at least if there's no easy cloud access, then you can host it on UCSC, one of the SOA servers. That doesn't really work that well, but at least on clouds it's possible.
So like the data set and should be stored in the cloud platform like AWS.
You'll see. I mean, if it's a large data set and we need to arrange some storage, we can set up like a S3 or Google Cloud Storage, like the GCS. And if it's a small data set, then we can figure out maybe different ways.
I don't know what you mean, like we can do it with the cloud.
The cloud thing is more for serving the trained model. So when you have a data set to train a model, right? On the live system, you don't need that data set at the back end. So let's say you train a language translation model and you use a large data set to train it. Then and then you host that as a web interface that you type a sentence and the result comes out as a translated sentence, right? Now the server for that doesn't really need the entire large data set on the server. It just needs a trained algorithm, the trained parameters. So a trained model, right? So that's what you're porting over to the cloud. But if you need live interaction with the data set, then we can look over those details. But in general scenario, when you're training the model, you need the data set, but you don't need the web server. When you're hosting the trained model, you'll use the web server, and then it's just a small thing you're putting in. It's just a model file. Yeah, so that would be the hosting portion. And each project has to be presented in the class, preferably a demo, maybe like 1 or 2 slides with just name and introduction and minor details, but the main part is the demo of how it's working, and then some coverage about what was the pipeline going through. And you also have to submit a short paper. I'm keeping this portion because it's a good practice, just to, like most of you are, almost all of you are graduate students. So it would just help like write a small paper about it, and maybe if you want, you can later on submit it to a workshop or a related venue. There are different venues for AI for social good, but it's a good practice basically. You build a project, it's an applied project, and you write a paper about it describing the problem, the data set, the method, so you have a system design, the evaluation results, so it can be a full, it can be a good short paper. Any questions around project? Nothing? Okay. So the group selection, we can do it in class. If you want, we can do it over Piazza. But there would be a stage when you'll be discussing ideas and creating groups. It would come later into the week. But that can be, we can also allocate time in class if you need to just find different partners or go over the ideas. It's a small class.
So the assignment is individual.
Yeah, assignments are good. Okay, so collaboration policy. The slide is stolen from Luca's slides. like he has this good collaboration policy in each class. This is basically saying that you can use any snippets of code from anywhere, but you have to give correct attribution, right? You can ask your classmates to advise, discuss ideas, even like exchange small snippets. You can even exchange them on Piazza. It's no, not a problem. But you cannot really get the entire answer from them. So 2 collab notebooks submitted in the work should not be really like identical or just variable change level identical. Like the solutions should be different. It's good to discuss things for help, but it cannot be a full copy. You can also not make your homework available on any public repos, just so that like even though you didn't directly share your solution with anyone, but you set it up and then someone else found it. So it's given a student account. If you want to host a Git repository, you can host it on Bitbucket for free. GitHub also has a student plan where you can do a private repository for free. So both GitHub or Bitbucket, whichever you prefer, can be used for private repos. So please keep the code in a private repo. Don't host it up on any public spaces. After the class is over, you're free to host it. You cannot use non-public web content. This is a good point in the policy. I'm really sure like it's not going to be a case, but you cannot hire anyone, like pay anyone to do this. Okay. But yeah. In homeworks, you must run in your own solutions. And for the project also, you can copy large portions. And these can be really large because if you're using different libraries, I don't want you to write the libraries. Just keep them as a part of your code. Since everything should be portable enough, you will have to actually put the libraries into your code. And you cannot just call them. But the real evaluation of the code would be on your contribution. The new content that you add, the new pieces of code, and the projects will be evaluated by me. And we'll have a presentation evaluation along with you. Right?
There's the presentations at the end.
Yeah.
I'll be here for those presentations.
So with Professor Davis, and the code of the projects will be evaluated by me, so you'll be required to submit code and the short paper. The short paper will also be. Other notices for students with disabilities, please submit to me the letter from DRC privately. You can contact me over mail. You can meet me in 239A, E2 239A from next week onwards. And right now, I don't think there's any need for permission codes, but if you need one, please let me know. I have a certain number of codes that I can provide. And there's an inquiry form as well on the site, which you can use or just email me directly. So now I'll sort of, in this small segment left, I'll go over some idea of how, of the process breakdown of applying machine learning to social good, and with a small case study. So this is just small coverage of the content. So if we want to break down like the process broadly of how you look at a societal challenge, right? And you build a solution for it, like a working solution for it. It can be broken into identification, definition, solution, and deployment. So identification means you're analyzing the challenge, your misinformation, right? That's a big problem. You're analyzing the larger problem and looking at like specific problems that you can find within it. So a challenge is a much broader space, and like United Nations has defined several challenges, and there are goals associated with those. So once you look at those challenges, you can figure out, okay, this is a particular problem that might be solvable, or maybe I can add some contribution to that problem. So identifying that particular space is first and the foremost thing, because it's a wide space, you don't know, right? And then defining it as a concrete problem where you have these tasks, which can be understood in the computer science language. That yes, I have a task, I can write a solution for it, right? So defining the problem into is maybe multiple tasks, maybe one big task, but sort of structuring it down finally. And then solution, which is the real thing. Okay, now you know what your problem is. You very clearly know what your problem is? Can you write a solution for it? Can you determine which machine learning algorithms work? Can you build a model to really make that happen? I mean, there are times when maybe machine learning would work, but the setting is so, let's say, time dependent that that solution is not working. So you have to figure out in detail, like self-driving or like automated vehicles, right? Autonomous vehicles. What happens is that yes, you can detect an object. Object detection learning algorithms are efficient; they work, but that problem requires the detection to happen within a very, very short period of time. Because if the car is moving at a certain speed and there's not enough time window to do that detection, right? So is your machine learning solution actually compliant to that time window? So it's not just about solving the problem, it's looking at multiple aspects of your solution, that whether it is deployable in the real scenario or not. Similar with the large data set. So okay, we built something which is like a 150 layer neural network, and it works really well. It gives state-of-the-art results, and now I want to deploy it in an area where the power supply is not like you don't have regular power supply, you don't have large computers, you really don't really have the compute power to run that neural network. And then that solution, even though it's a great solution on a particular data set, is not a practical solution. So looking at the practical aspect of it. So the solution is a big stage where you are using machine learning, but understanding the limitations of machine learning at the same time with respect to the problem. Maybe the best solution is not the best accuracy solution. The solution is the smallest model. So depending on different scenarios, how is your solution going to be effective? That's a part of this stage. And then the final stage is deployment, where you figure out that how are you going to build a real working system out of your machine learning approach? How are you going to deliver it? So for misinformation, for example, we have a system where right now, what's the real problem? Fake news is out there. People are creating fake news, people are spreading fake news. So creation is one problem, but spreading is even the larger problem, right? Even if you get 10 articles per day, but then it just spreads out to millions of people, that's the real problem. So if the people are aware that, yes, this is a problem, and they can maybe take a very easy step going into it, right? To just detect whether it's working. So one of the hackathon solutions by some students, I mean, it was, so ML-wise, it wasn't a great solution, but deployment-wise, I think it was excellent, was that they built a small widget, the app thing, like on a Google Chrome browser. You know, the extensions, or it's not a big extensions that you can add on Google Chrome browser. It was just an extension that if you visit a web page, it's going to give you whether it's a reliable web page or not, whether the content going in is going to be reliable or not. So they had more of a static learning method associated with it, like maybe detecting on sources, but that's a controllable component. You can have your fully, like a very strong, well-trained machine learning model running behind it. But delivery is easy. You're not putting in so much pressure at the final reader, oh, take this and go and validate it. No, you're actually serving it as an API or an extension where the user, if they want to really avoid reading, if they want to read genuine information and they care about that portion, the overhead is not too much. It's easy access. So deployment comes, deployment again touches several real aspects. Like solving the problem is one thing, but making it accessible to users, making it work without really asking them to do everything. So, but yes, we have a solution that exists somewhere, figure it out and use the model. If it says this, then yes, it's a fake. No, I mean, you don't want to put burden on them. So deployment is a really important component out of it.
So again, and this may be a tricky question, but since this class is supposed to be talking about ML for good society. I mean, so with that algorithm as an example, how do you evaluate whether that actually is in the interest of society or not, right? I mean, there's certainly, I've never read this paper. I've just heard about this today, but immediately you said that, okay, or Raphael said that this was basically working based on who gave this news, what the source of this news was, for whether it was fake or not.
Yes.
Right. So this sounds like it's just silencing some people, and not other people, or labeling some people fake news.
No. So this is looking at the source in terms of the website from where this news is coming. So you're trying to identify sites which are less reliable, right? And the distribution, the people that come in the picture are basically you are saying, okay, there is enough evidence to claim that yes, information coming in from a certain site is unreliable. These are sites hosted up for fake news distribution. There are several sites which have been identified like that. Only based on that information, when you start that as that's your ground truth. You're not assuming anything else, right? Then can you make a model of people who are distributing this news more and more to associate less reliability on their distribution? People who are distributing news more from valid sites like Reuters or like definitely news sites which are curated, sites where journalists are putting in content and they have been doing that for years, New York Times and much reliable websites, starting with a higher weight from those sites, and then training the permutation. So you have, it's called a harmonic model, where from one side, you started with a small reliability, right? You said, okay, let me just take these few websites, which are definitely famous for fake news, which are known for fake news.
Well, hold on, let me stop you there, right? Okay, so that's the question right there. So these sites are definitely famous for fake news. I absolutely agree with you 100%. There are some sites which just put out fake news, and some sites which are particularly famous for it, like those of the Breitbart organization.
Breitbart won't be that. Breitbart is, I would say, it's not guaranteed to put fake news. It's very one-sided, right? They have their opinion, but it's not that they will always put fake news. Infowars, I would say yes. I mean, as they like Alex Jones claimed, he doesn't care. It's going to be fake news. So you're not putting in the unreliable. So because of this perpetration, what happens is that Fox News goes closer to those sites, but the fake news detection doesn't increase up because Fox News also has good enough matching with the reliable sites. So that's because of the what I'm saying. They are opinionated, right? So Breitbart is not a fake news platform. Fake news platform is really fake news. That's why I'm saying we have a very small number of those ground truth values, which are some like people have confirmed. There are companies around it like Metasert who are really doing this investigation of because if I like the same problem Twitter was facing or Facebook is facing, both were facing as well. That they cannot just block an account. You cannot go and block an account based on certain opinions, right? You have to have enough evidence to say that now this is fake or this is hate, right? There has to be a certain bar which, when crossed, is your label. You're not labeling anything before that. But now using the associated label, you are associating a score for the different news articles. That's the idea. We are not claiming anything just on an opinionated basis.
All right, so you guys are starting off with this list already of what are the fake news sites?
A small subset of that list. Then using it to evaluate the
On whether
detections.
users are likely to have gotten this from a fake news site.
Yes.
Okay. Yeah. So and that original list of fake news sites, where does that come from?
There are two publicly available. One is publicly available. One is hosted by a particular company, Metasert. The other is called open sources. This is publicly maintained. So if you, I think, I have the link for it. I don't remember the name, but it's available and well validated.
I mean, this sounds like a really cool idea to me. I mean, generally, like people talk a lot these days about concerns that ML will be used in ways that we think is good, but turns out to be negative.
That is when you're not checked. That's why evaluation is a big component. If, let's say, I put in Breitbart, right? Let's say I put Breitbart in that list because, I mean, I don't like their articles. So they're fake. If I claim that and start putting in, and then train my model, I'm pretty sure Fox News will go in the fake direction, which is not true. I mean, opinion and truth are different things. You can have any kind of opinion, but if it's true, it's not fake news. And but if I don't make that check starting in my process, right? If I'm not doing it responsibly, yeah, ML can lead to a very bad result. And
I think you're raising a really interesting point, which I'm sure this class will end up discussing. But whenever you talk about you're solving a social issue, it invariably comes down to from whose point of view, right? Right? Because like if I train exactly the same algorithm and start with a different set of sites, right? So okay, if I'm at the other end of the political spectrum, let's start with NPR. Right? And like we put in some more like that, we're gonna get a different list of things out at the end, right? And clearly your input data is gonna affect what's good or not. And I can come to lots of social problems where we can probably split the people in this room, for which half say you're making the problem worse if you do that, and half say no, you're fixing the social problem because we don't even agree which way society should go, right? So like I think the question that you're getting at is something we don't normally deal with in engineering, right? In engineering we have an answer, right? But like okay, now you're verging into sociology, and like people don't agree how the world should be, and so like what is fake news? Well, you may get 90% agreement on that one, but I'm pretty sure we can come up with other problems which we don't like people are not like, what you should do. But I think the steps that he's talking about for going through solving these problems, well, they apply on both sides. Okay, so half of the room is going to work to increase X, and half the room is going to work to decrease X. But right, because they do the social issue the opposite way. But I think the way to think about the problem is going to apply. So I think you're raising a great point, right? Like,
And there's like more nuance to that as well. It's not always just binary, right?
No, it's not. I don't mean to imply that it's always binary. But like, this is something I like to do in my classes. It's like, okay, you think you're solving this problem. Okay, well, now who thinks X? And you come to the logical. Like normally, usually people don't phrase exactly against each other. But like, if you think X, that implies Y, Z, right? And then if you think Z, that implies negative Y, negative X, right? And like, you come to a point, right? So I think this question of like which sites go in, yeah, that's the kind of like if we're training machine learning stuff, that has to be thought about deeply, right? And somehow exposed to the consumers of that information, they're gonna.
And yeah, and exactly, and how, and as people who are developing this stuff, what kind of systematic process can we have to evaluate ourselves and ask ourselves, are we actually doing something that's good here, or are we doing something that sounds cool?
That I think is interesting. But I predict this question. I don't know exactly what is that. I think evaluating for yourself, but I think it's two different things, right? So I think convincing yourself that you're actually doing it, not just being cool. That I think people have thought
about. I mean, we'll come at more discussions on this, but one point that you raised is the responsible part. That's a topic of major concern. I mean, yes, so AI is a tool. AI and machine learning, they are tools. They don't know the thing going in, they don't know the thing coming out. That's a part of the person responsible for it. And I think that no one really has the best answer yet, but one thing which is required from the computer science people is to be more open to people who are experts in those domains when we are talking about those domains, right? Like, let's say this becomes a field, like AI for social good is a field, and we are really going in deploying systems. Then, like us, if we judge, okay, this is probably the best solution for people in agriculture or people in health, right? And not talking to people in health, just figuring out because we have access to a data set that they created and this is what we discovered. That's sort of the weak approach. That is not responsible AI. Responsible AI is when you have the correct stakeholders involved into the process of building a system, and your objective is to solve the problem. Your objective is not to be the one coming up with a solution. And the problem might not get solved. You can always come up with a solution.
So your objective is to solve the problem, not to be the one coming up with a solution.
Yeah. So you can come up with several solutions.
Sorry, those two, I missed them.
So what I'm saying is, coming up with a solution is easier than solving the problem.
Oh, coming up with we're the ones that solve the problem, not the ones who come up with the problem statement.
And, see, there's a real problem, right? It's not a problem where you have an answer. That's my main concern. That problems in real world, problems of social good, are not problems with a definite answer. You can maybe help into that, and that's what you're aiming to do. You're trying to build solutions to do that. But the ultimate goal going into the process for you is to really solve a problem. It's not to be the one coming up with the best solution or to just be someone who has a part of the solution. I mean, if I come up with a solution which seems like it seems to do some validation, but is not really solving the real problem at all, then it's not a good solution at all, right? But I can still come up with it. I can show in terms of data sets real results, but do they apply to the problem at hand? Do they apply to the problem in totality? That's a major concern. So that's what I'm saying with that you really want to build something to solve the problem and not want to be someone to just demonstrate a small solution. It's a wider space. You can probably show that yes, it works within a validation data set, right? Find a validation data set where this works. But maybe it's not the full solution yet.
I can give an example of this. I was just at a workshop at Microsoft Research, and it was a set of people interested in doing tools for deaf people, right? So you might expect sign language recognition, right? There's dozens of papers on sign language recognition. So we acquire computer vision. Can we tell the signs? Can we know what people are doing? And then we can have translation systems. The complaint from the deaf people in that set of people in the workshop was, well, those are all nice, right? Nice academic papers, 99% accuracy. They work on 100 signs. Real people don't talk with 100 words. So useless, right? So I think this is an example of like, I build a solution, it does something, like I got my good numbers, like good, right paper. But the potential user set was like, what? This is what, right? Like, I can't use that thing, right? Like, it doesn't have anything, right? And so like you're in reverse stuff, right? So it's the same kind of thing. I think the point is, in academia, we frequently build toy problems, and that's useful because it allows us to get at something. But when you start to go down this space and you're trying to do something, you have to look at the wider evaluation also. And you may still build a toy problem to get steps there, but you want to be careful about misthinking that your toy problem is
It's a solution.
It's the solution to the whole problem. I think this is the point.
Okay, that's good.
So I also have like some details over these 4 stages, but I think we have covered those well enough, and it's 5 minutes left. So I want to introduce you to a small case study, quickly going over identification, figuring out the problem, the societal challenge, right, which is really broad, breaking down into smaller problems, maybe some things that are solvable. You can find solutions for them, right? And then if you can solve any of those, maybe that can contribute to a significant, that can make a significant difference. So for example, like misinformation, the way it's impacting democracies is a really big challenge. But if I can control fake news, detection of fake news content, right? Social spread of unverified information, if I can control that, that small space, or maybe like I see there's a problem that is the lack of validation resources. So you can break a real challenge into several problems. Then you can define tasks, right? So once a real world problem is defined, you can structure it into a solvable problem. You can then build your machine learning objective. Okay, this is what my problem is going to look at. This is the data set that I would need. And you now have a definition, you have a structure. So like to control the social spread of unverified information, this is similar to the work that we did. We want to associate a reliability to the information that is being transmitted, which is being done by associating the trust to the source of that information. So information is the one at hand, right? The article is the point of concern in fake news detection. But the source from which that article is emerging, you can also learn a trust for that, and maybe a machine learning solution for that is possible. So that's the definition of your problem into a smaller problem. You find a solution for it. You have a clear list of tasks. You can find different ML algorithms that seem to be able to solve problems because now you have a definition, right? So you will understand, okay, I can break it down into a classification problem, or if the data looks like this and the output is a classification result, there is a family of algorithms that can probably work well. Let's try those. So you're writing the solution and you're evaluating it. And then you're deploying it because you want to deliver that solution to the people under concern. Your problem does not stop at just building the solution. So that's the final deployment stage. One very good example, which, so TensorFlow was made public in 2015, late 2015, November, right? Since then, access to this full-fledged library that allows you to build neural network systems and neural networks. Basically that was a good starting point for anyone to start applying deep learning. There used to be a library called CAM before that, but it was more for people who are doing research. TensorFlow is more accessible in that sense. So they hosted this very nice post on their first TensorFlow Summit, which was a Japanese cucumber farmer who used deep learning based system to identify different categories of cucumbers. So the real idea was that his parents were cucumber farmers, and they had so during the when there's the best season, they have a really large number of cucumbers, and they want to categorize them because that's how they are going to be sold in the market. So ones with more thorns and which are more straight are going to be the best. Ones which are curved not going to be in that best category, and they have their own categorization system. And the engineer's mother was doing manual sorting of these things. And since it's in the primary time zone, primary time period, they cannot even hire much help just to do that seasonal job. So basically it's a task where they are farmers. They can be doing more plantation actually to develop improve their status, but this is a portion where they have to spend a lot of time. Yeah, maybe that's something machine learning can solve. And this person, I have mapped his problem to identification, definition, solution, and deployment. But what he did was that he figured that the problem is that cucumber farmers can work more on plantation, but they are spending up to 8 hours a day just on sorting, just on putting the cucumbers into correct sorting, right? So can there be a system which can be developed for sorting cucumbers? Can that be the definition which we need? Solution is yes. I mean, you can build an image classification system, train it for those categories, right? Because you can generate a label data set. You can do a manual task once, create a data set, and then train a machine learning model on top of it. But okay, that's good. Like you take a photo, but you really need a real system, right? It's cucumbers. It's not images just being classified. It's not. The result is not going to be in the terms of accuracy. The result is going to be in terms of 10 baskets of cucumbers for 10 categories. So how can you build that final piece of system? And this person built a 3 pipeline thing where you have a Raspberry Pi, which has a camera attached to it, which is taking the image of the cucumber. So you put the cucumber on the panel, it takes the image, performs the classification on a trained model, and then there was an Arduino-based pipeline attached. Like you build a small conveyor belt with 2 motors and a small microprocessor, and you associate when is it really going to drop into one of those baskets. So this is the pipeline. It's accessible on the website, but let's look at a small video of how it works. So that's basically classification in the manual context. The system has classified and it has alerted which folks should really put it into the basket, and it's working that way.
Wow, it just seems to take longer than sorting.
But
solution.
This is a systematic problem with engineers building things for social good, right? Which I hope will come out throughout this class. It's like you build systems like this, And you say, okay, we built the whole system, we're done. Like, there's a lot more steps of like, go talk to some farmers. Like, okay, yeah, takes longer. Also, I used a hammer to hit the cucumber before I'm about to sell it. That doesn't seem great. Like, there's all kind of things that you can't even predict in advance. Like, you go, like, but that's a whole other step. Like, if you really get into like doing things with social issues, you end up doing the half sociology work. Like, you have to go see what actually happened. Like, did you get an outcome that you want? I think it's useful to the world both to do the technology only work and ignore that piece, right? And I think most engineers actually prefer that. But it's also useful to have people that understand both sides and think about what's going on. So like, most successful things, there's a whole piece of like actually working with, usually you find a nonprofit organization that's working on whatever you're working on, because they understand the social side in a way that you probably never will, right? And so like this comment that you're making, no, this is, like, that's not done.
Yeah.
Like, just because they turned the algorithm into like, I can kick cucumbers, right? Like, that's not done.
There's still someone who's putting even that can be automated, right? So there are several pieces. Another thing that
Do stuff for social good. I mean, here in engineering design, shouldn't you be concerned about the outcome? When you know, if you come from the perspective of, say, nano-biomedical devices, I have to know the problem before I can. I have to know both sides. Of course, mine wouldn't be too social; it'd be more involving the basic sciences. You know, what is the problem when you're designing a medical device or cardiac therapy or bionic vision? You really want to know the biology and the physics behind it, which is kind of like knowing the social problem in order to effectively bring something to the market that's useful. So, shouldn't you, as an engineer, try to know both, a little bit, not everything, but both sides, in order to?
I think there's room for all. You actually brought up the other side. I was saying that you have to evaluate at the end. In fact, to even know which problems that you're trying to solve usually involves field work with an organization to figure out what is the problem. Because most nonprofits I've talked to don't come and say, okay, what I really need is a neural network here, right? Like that's not how they describe their problem, right? So like, you have to go figure out what they're talking about, learn enough about their area to be able to phrase the problem, right? Come up with a solution, and then evaluate with them. Almost every project that I've seen that's successful working on sort of engineers with social issues has been a partnership with domain experts, whether that's a nonprofit or that's the doctors, potentially in your case or whatever. Like you can't be an expert in everything. You're going to be an expert in computer science or whichever field you're studying, and you're going to have to learn enough about what they're doing. You're going to have to learn enough about what you're doing, and you're going to try to bridge. You're going to have partners on both sides. The comment that I think is useful is there's room in the world for people who are sort of like 1/3 of their brain is about this social issue, 1/3 is about engineering, 1/3 is about this, where you really sort of involved, all the pieces. I think there's need in the world for those kind of people. But just because if you think like my preference is really to work on the technology piece, but I need that in the world too, right? Everybody is sort of 1/3 everywhere. I don't have the experts who can really count on, right? So taking cucumbers or sign language recognition, I need somebody who understands how to frame the problem. Eventually, you're going to get to this core. Have a stack of images. I don't know which kind of cucumber it is. That's a contained problem. So now I can take somebody else who doesn't understand social issues, doesn't know how to evaluate. Say like, I don't know, just beat on this, give me 99%. Right? And so like I need people in the world that can do that. So I think both. Right? Like I need people who understand the problem, but I don't need every engineer to understand the problem in order to be able to work. That's my observation from looking at lots of projects, but that's subjective.
And even like in this example, the farmer, the engineer who was working on this said that they built a small data set of 7,000 images, which is for neuron, it's pretty small. And they had a 90% accuracy in validation. So when they're really training a model, the validation data set says 90% accuracy. So if my work stops over there, right? If I'm an engineer or if I'm writing a paper, it's done. I publish a paper, 90% accuracy. But same thing, same model taken into the real evaluation set, like real setting, and then he continued to evaluate it. It was like 70% accuracy. So then you need a much larger model or much more data set. So this is another example of realizing that validation, like the score associated with validation of a data set, is just a part of the story. If that's bad, everything is bad. But if that's good, that doesn't mean things are solved. So that's one example. I think we're out of time. So thank you so much. See you on Thursday.